Hey there, Vincent here with another Alibre tutorial. Today we're going to go over Too Tall Toby's 231203 Hex Arm. And yeah, so let's just get started. So before we get started, let's take a look at the drawing to see what we're working with and how I kind of analyzed and approached doing this part. 1 second. Okay. So if we look at, so let's look at the drawing over here. Looking at the part, basically how I understood it is that there are essentially two separate pieces I need to create, and then I need to create a loft between the two. So here I'm referring to this D-shaped part, and then here the cylinder, and then after I create the two pieces, I can then loft from one piece to another. The tricky part of creating this part is that there's this ellipse profile that goes from one part to another, but it needs to follow these guidelines in order to do that. So not only that, but from the top view, that this ellipsis that gets lofted has a constant width of 26, so we need to figure that in as well. But for the rest of the part, it's fairly simple. Here for the hole over here, we can basically just use the Alibre's hole tool, make a counterbore hole, and that should suffice. The front piece is a little bit more tricky because I don't think there's the built-in hole tool has a way to define a hole that has this kind of shape with this canonical tip. So my approach was that to just do it in two pieces, use the regular hole tool to create this first part, and then from the bottom piece, from the bottom part, I just created a sketch and did a revolve cut. And yeah, so that's basically the strategy. So now let's just get started. So in Alibre, first thing I'm going to do is I'm going to create that. Oops, moved it out of the way. Let me realign it. In Alibre, the first thing I'm going to do is I'm going to create that D shape. In order to do that, I'm just going to create a sketch on this XY plane. And for that D shape, I'm going to do it in two pieces. The first thing I'm going to do is add a rectangle and add the dimensions. So the D shape is going to be comprised of a rectangle and then a tangent arc between one of the edges to create that curve shaped in the D. So in the rectangle, I'm going to add the dimensions 44 and 65. Now we don't need this last edge in the D shape, so right off the bat, I'm just going to trim it. Yes, and I know I need to add this dimension back in of 65. I'm going to add a symmetry constraint along the x-axis for these top two edges. And then let's see, what else can move? Oh yeah, finally, this D shape can still move. So in order to constrain that, I'm going to add a midpoint constraint between this point, and the center over here. So now everything is nice and centered. In order to add the curve, like I said, I go to the arc tool up here, select tangent arc, and I just create a tangent arc to close off the shape. And that's done. So now that that's fully defined, I'm going to deactivate the sketch. I'm going to do an extrude. And from the top view, it says that the width of this is 40. The type of extrude I'm using is going to be mid-plane, so to keep everything centered along the axes. And I'm going to click OK. Next thing I'm going to do is I'm going to move on to the cylinder part. And to do that, I'm going to create a sketch on the ZX plane. And on the ZX plane, I'm going to use the circle tool to create a circle. And from here, it says the diameter of the circle is 30, so I'm going to put that in. Now we need to figure out the distance between this part and the cylinder. And in the diagram, it tells us the distance between the center of the circle to the center of the hex. You can also think of the center of the hex is also equivalent to the center of this tangent arc. It says that distance is 125. And then we also know the length over here is 44. So if we just add the dimension from the front of this D part to the center of the cylinder, that would be the 125 plus 44 would give us the correct position. So that's what we're going to do. So in order to do that, I'm going to project a reference to this D part, and I'm going to add the distance between this point and this point, and that's going to be the 125 plus the 44, which gives us 169. Now the last thing is we need to make sure that this is centered along this x-axis, so I'm going to use a coincident constraint. select the center of the circle, select the x-axis, and now that's fully constrained. I'm going to deactivate the sketch, and now I need to extrude. And it says from the drawing that the height of this cylinder is 48. So I'm going to put that in, 48. And for the type, I'm going to use mid-plane as well, and that's done. Now we're going to create the two profiles that we want to loft from. In order to do that, we also need to define the guidelines for the loft. But before we do anything, what I'm going to do is I'm going to first insert an axis that goes through the center of the cylinder. This allows me to create a sketch that is right in the middle of the cylinder, which I will use to loft to this piece. I'm going to create that axis. And actually, I'm going to create that axis first and close. Now what I'm going to do is I'm going to create that sketch that defines the two guidelines. So in order to do that, I'm going to create a sketch on the XY plane. I'm going to project in the D shape, create reference figure, maintain association. I'm going to also, actually that should be good enough. So from that, I just use the line tool over here. I'm just going to first just kind of rough in two lines. These two lines, I'm going to use a symmetry constraint along the x-axis to make them equal. Now I can add an angle between the two, and we're going to specify that 10-degree angle. On the diagram, it says that this from this view, this line needs to be tangent to this D part, so I'm going to add using the tangent constraint. So click on this line, click on this curve, and now it's tangent. Now the reason why we added that axis is so that we can have a point of intersection for when the ellipsis from one profile, where the ellipsis of the profile is drawn for the cylinder is drawn. So in order to do that, I can just pick one of these points, select the coincidence constraint, click on the point, and then click on the axis. And now this guideline sketch is fully defined. So I'm going to deactivate that sketch. Actually, I'm going to go back in and edit the sketch, because one thing that I will need is I will need to be able to create a profile or a plane along that intersects with the point that is tangent to this, or this point that is tangent to this part. I need that plane in order to create that ellipse profile. So in order to do that, I need to create a plane that intersects with this point. And in order to do that, I need a point to reference. So that's why I'm back in this sketch. From the top here, it says insert point from sketch. I'm gonna click on that, and then click on this point, and then click apply and close. So now we have that point that we can reference. Okay, so let's just create the first profile. I'm gonna create the first profile from the center of this cylinder first. In order to do that, I need a plane along the center that goes through the center of this cylinder. So I'm going to create insert plane. I'm going to clear everything over here. But what I need to do is I'm going to click on this insert. Which option is this? Rotation of a plane. Okay. But I'm not actually going to do any rotation. All I need to do is select the axis, and then as well as the referring plane, which is this YZ plane. And then now it creates a plane that goes through the center of this cylinder. That's good. So I'm going to click apply and close. I can now create a sketch on this plane. And from here, I'm going to project the guidelines that we created. So in my case here, that would be sketch 3. I'm going to create reference figure, maintain association. Okay. Here we can see that we need to create an ellipse that intersects with these 2 points. So from here, in the sketch, I'm going to add the ellipse. Using the ellipse tool, I'll click on that. Start from the center. I'm just gonna sketch it out first, and then define it later. Here, since we want that constant width of 26, we can add that dimension from this point to the center of the ellipse as 26/2, because we're doing half of that. And then also we need this point of the ellipse to intersect with that guide line. So here, in order to do that, we add a coincident constraint from this point to the line, and that didn't work somehow. Oh, okay, so it's down here. Sorry, this point to one of these lines. There we go. Now it's fully constrained. That's one profile that we're going to use to loft. Next thing is we need to create a profile starting that intersects with this point of tangency. So in order to do that, we need to create a plane that touches this point. And to do that, we'll use the plane tool again. This time I'm going to use, and I don't know, it's kind of confusing which option to use. You just kind of have to play around with it. But I know that what works with the point is just this default plane offset creation method. In order to do that, I'm going to select the plane that I want to offset from, which is the YZ plane, and then select the point that I want it to offset to, and that creates that plane that is that intersects that tangent point. I'm going to click apply and close out of it. Now I can create a sketch on this plane, and I'm just going to click reset view, so spin it around so I can look at it from the back side. Here I'm going to go and project in those guidelines again, which is sketch 3. Create reference figure, maintain association, click OK. And then also now, similar to before, I'm going to rough in that ellipses and then put in the dimensions. So from the center to this would be 26/2 or 13. And then we want to also make this point coincident with the guideline. Now that's fully defined. And yeah, so now that we have both of these profiles, we can now use the Loft tool. Loft tool, I'm going to specify sketch 4 and sketch 5. That's what I want to loft between. And this already looks really good even without using guidelines, but or using guides. But for completion's sake, I'm going to go down to guides, select global, and then I'm going to select sketch 3 as our guide, and then click OK. So that is pretty much the hard part done. So now I just need to go actually create. So a couple more things to finish this off. I need to create a hole over here, create that hex hole in the front here, and then a hole from the top down. So let's just actually do this tail first, because that's the easiest. I can just use the hole tool in Alibre. Wait for that to open up. Select the counterboard option, select the face that I want to drill a hole in. Just rough in where that hole should be. And then let's see, what is the specification for this hole? The width of the diameter is 11. The top part is 20. It goes down 9. And then the depth condition is through all. I'm gonna click OK. And now notice it's not centered yet, but it did create a sketch. So I'm gonna go in and edit that sketch for this hole. And in order to center it, I just need to project in this face, create reference figure, maintain association, and then make the hole coincident or concentric or coincident with the center of this point over here. And now the hole is centered. Okay, now let's go back to the front of this piece. Before we do anything, let's add these curved these fillets up here. So here I'm going to use the fillet tool. Select this edge, and from the diagram it says the radius is 20, so I'm going to specify that fillet of 20. What I'm also going to do, because I will need to do this later, is also create an axis. We know that we said that the hole, we broke it down into 2 parts. Use the regular hole for the first half, and then use a revolve cut around the second half. So in order to use a revolve cut, I need an axis to revolve around. So I'm just going to go and create that axis now by using insert axis, select this face to insert the axis from, and click apply. Okay, so let's see what to do first. Yeah, so let's actually make that hex cutout first. In order to do that, I'm going to create a new sketch along this XY plane, and then I'm also going to project in some references. And here, in order to actually make the hexagon, I'm going to use the polygon tool. By default, it's 6, which is perfect for us. I'm going to select the center over here and click apply. And here it says that the height from one side to another is 35. That is the same thing as defining the diameter of this reference circle. So I'm just going to go and define the diameter of this reference circle to 35, and that's how we get that dimension in. I also just need to select one of these edges, this top edge, to make horizontal, and that makes this fully constrained. But it also cuts out from the front, so in order to do that, I'm just going to insert a rectangle. From here, I don't need this right edge on the rectangle, so I'm just going to trim that out. So similar to before, I'm going to create a symmetry constraint along the x-axis between the top and bottom edges. I'm going to add in the dimension of the width of this cutout, which is 10. And then I also need to have this point touch the hexagon. So I'm going to add a coincidence constraint. I'm going to click on this point and then click on the edge of this hexagon, and now it's touching. It's still not fully constrained yet because this part is still free moving. So I can just add a vertical constraint between these 2 points. So that's what I'm going to do. Vertical constraint, click on one of these points, click on the top. Now that's fully defined. It is fully defined, but there are these extra edges over here. Previously, I tried just trimming those edges, but then it, basically got rid of all of the definitions of the hexagon. And then if I did trim it, I would need to redefine everything, which is kind of annoying. So I'm not going to do that. A shortcut is to just make these existing edges into reference figures, which is what I'm going to do. And then just draw in that line. Just complete or enclose that sketch myself by drawing in the lines. And that should be done. So now we have, I'm going to deactivate that sketch, and now I'm just going to do a cut, extrude cut, and I'm just going to use through all. All right, so last piece is to make that hole through so it's in 2 parts, the first part and the second part. Let's do the first part first. So in order to make the hole through the first part, I'm just going to use the hole tool. Again, counter bore option, select this face. I'm just going to rough it in somewhere over here. And it says, okay, let's look at the specifications. The diameter of the hole is 10. The top is 18. It goes down, recessed 8. And then instead of through all, I only wanted to select the option to limit geometry. So this is similar to extrude, where you can select 2 geometry to extrude to. This is exactly the same thing, but the hole, I'm going to limit the cut all the way down to this face over here, and then click OK. Now, in order to align it, I'm going to go back in and edit that sketch. I need to project that face in order to get that reference, the center of that arc, to make it all aligned. So here's the hole. Here's the center I want to align to. So again, I use a coincidence constraint, select the hole, select the center of the arc, deactivate sketch, and now the cut or the hole is centered. Now the last bit, I'm going to do a manual revolve to get that canonical cut. So in order to do that, I'm just going to create another sketch on this XY plane. I'm going to project in some figures for reference. So reference and maintain association. Now I'm just going to rough out that shape first. So starting from, so again, here's where our axis is. So starting from over here, draw a line across, draw a line down. So it goes down quite some bit. Let's try to make it so we can get that parallel or that vertical constraint automatic. Perfect. And then there's some angle that needs to be, and then goes back up to this point. Okay. So we know from the diagram that says that the diameter of this bottom half is 7. Since we're only dealing with half of it, since we're going to be using a revolve, that means we want half of 7, which is 3.5. Is the width. And oops, 3.5. There we go. And then we also know that there's a 10 millimeter offset from the bottom of the piece, so we're going to add that in. 10 millimeters. Let's just move this around. And then also there's this canonical tip. In the diagram, it says the angle is 110, but since we're doing half of that, would be 110 over 2. And that's done. And now we're fully defined. So now we can deactivate the sketch, use the revolve cut. For the axis, we select that axis that we created way earlier, and that's up here, that goes right through the center of this hole. And 360, okay. And that is that. That is our part. So in order to check our work, let's go to Material, select from the Material Library, and do that 1060 alloy, click Apply. Go to Inspect, Physical Properties, Calculate, and we get a mass of 0.6268 kilograms. In order to get grams, you multiply that by 1,000. So 0.626 626, or around 626 to 627 grams, which is our solution. And if we go back to the video, let's play that, goes to the solution. Boom, solution 626 grams. So yep, that is pretty much it. This is the part. Thank you for watching.